Alright, it's Mr. Piels with Algebra 2. This is Unit 1, Topic 1, SLT4. When given a function, we're going to determine its inverse relation. Are the two graphs below inverses? Explain how you know. They are inverses because they are a reflection over the y equals x. Now, another way that I know is that I can simply count the distance to each point. Now, the origin, if you go diagonally, 1, 2, 3, and go this one, 1, 2, 3, they are both equal distant away from the y equals x line. So that's the reason I know that these two are inverse. No matter where you go along this line, it's going to be 3 away from that y equals x, and this is also going to be 3 away from that y equals x. Alright, so given a function, determine if it's inverse relation. Alright, so Bernie's bike shop. So the table below represents some of the signs that Bernie's created. So the amount of ink size, amount of ink needed, and the size of the poster are relative to each other here. So we've got 3 to 9, so that function, it looks like 3 times itself is 9, 4 times itself is 16, so it looks like x is simply squared. So that's simply the function right there. So I'm going to call this length, so length versus ink, or feet in ounces. There we go. We'll go with that. So feet per ounce is equal to x squared. Alright, so the domain. So I need to graph this. So the length of the sign in feet going this way, and this way is going to be the amount of ink in ounces. And feet, I need to go up to at least 15, so I'm going to go by 5s. Actually, no, I'll go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then these numbers go all the way up to 225, so I'm going to go by 25. 25, 50, 75, 100. 125, 150, 175, 200. Notice that I'm not labeling every single one. And there we go, 300. Alright, so now all I got to do is plot the numbers. So that's 3, 9. So this is 2, that's 3. 3, 9 would be about right there. 2, 4 is even lower. 4, 16, not quite up to the first mark yet. 15, 12, 14, 15, 225. Alright, so it's going to end up looking like this. Now, it looks like a hyperbola, but actually this is a quadratic equation. You just can't see the other side of the parabola. Alright, so domain in this case, because negative ounces or negative feet makes no sense. You can't make a poster that's less than nothing. So negative doesn't make any sense in this case. So we'd say that x is greater than 0. And I'm also going to say 0 doesn't make sense because you can't have a poster that's 0 feet big. The range, the height, it starts here. Remember, domain is left to right. So domain is all the possible inputs, and range is all the possible outputs. So that's the height. So that's going to be y is also greater than 0. Now, when we do this question, it's the exact same thing, but it's going to be the inverse. So this is going to be 9, 3, and then we're going to simply change the number. So this is going to be ounces over here, and feet over here. Plot the exact same numbers, 416, 2, 4, so 416, 2, 4, and 225, 15. Alright, so this is going to be our new x, and this is going to be our new y. So now it looks like this is the inverse. Instead of multiplying by itself, it looks like we're taking the square root of the number. So O per f, O of f, is equal to the square root of x. So this is our x, this is our y. Alright, so the domain this time. So it's going to be x is greater than 0 and y is greater than 0. And the reason I know that is because when you're finding the inverse, simply the domain and the ranges are just going to simply switch spots, which you're going to see in the next question as well. So I would graph these, I put the numbers, I basically would do the exact same graph that's over here, but putting these numbers on the bottom and those numbers on the top. So basically you have feet as going up as your dependent variable and ounces as your independent variable. Alright, so I'm going to get to this question because I know that I'm going to be limited on time on the video. So type of function. So this is a quadratic. And the reason I know it's quadratic is because anything x squared is quadratic. Anything that's multiplied by x is going to be linear. So this is quadratic, and this is linear. Alright, so now that we have identified what type of function it is and the reason why, now let's graph it. Now this is x squared would look just like this. But this is x squared minus 1. So if I put 0 in for x, 0 times itself is 0, minus 1 is negative 1. If I put 1, 1 times 1 is 1, minus 1 is 0. Now I know the other side of the parabola is going to be exactly the same. If I put 2 in there, 2 squared is 4, 4 minus 1 is 3. So 2, 1, 2, 3. Other side is going to be the exact same. So if I put negative 2 and negative 2 squared is also 4, 4 minus 1 is still 3. And there you go. So that's what the original function looks like. Now, domain left to right, that would be infinite. All real numbers because it's going infinitely left and infinitely right. Range, meaning the height, the lowest it possibly goes is negative 1. So y has to be greater than or equal to, it can be negative 1, and it can be anything that's above negative 1. So it can be anything greater than negative 1. All right, so the inverse. So now here I've got squared and then add. So the opposite operations in the opposite order would be x plus 1. So instead of subtracting 1 last, you're adding 1 first. And then instead of, and I didn't really need those parentheses, but it didn't hurt. Instead of squaring the number, you're doing square root. All right, so this is a square root function. And the problem with this is technically it's not a function. So I'm going to cross this off. Technically, this is just a relation because square root of a number it can't be a function if it's going to go like this. Because then it would be a lot of places that have one domain would have more than one range. So we're going to limit the domains. Or we're going to limit the range, actually, I guess. We're going to limit the height of the graph in this case. But we want to first, do the inverse. So this is 0, negative 1, so that's going to become negative 1, 0. This is negative 1, 0, and that's going to become 0, negative 1, so that's this point. In fact, I better change colors here because we've used 2 points that are exactly the same. This is 1, 0, that's 0, 1. That's going to become 2, 3 becomes 3, 2, 1, 2, 3, 1, 2. And it's going to look like this. Now, like I said before, this is not a function. So I'm going to limit the range to only the upper half. So I'm going to say the range is from y is greater than or equal to 0. And the domain is going to be anything that is x is greater than or equal to negative 1. Now, like I said before, almost always the domain and the range are going to be the exact same, just in reverse for inverses. But in this case, since it's not a function, it would have been the exact same. It would have been all real numbers for the range up and down, but then that would be not a function. So I had to limit the range. All right, so number 5. Linear equation. So a little bit easier this time. So I'm just going to simply graph I'm going to graph it y equals mx plus b. So plus 2 is the y-intercept. Slope is 3, 1, 2, 3, up 3, right 1, 1, 2, 3, up 3, right 1. All right, so that gives us the original function, or down 1, 2, 3, left 1, down 1, 2, 3, left 1 is the exact same thing. All right, so the domain is going to be all real numbers because this function goes left or right infinitely, and it also has a range of all real numbers because it goes up and down infinitely. The inverse of that, so that's multiply by 3 plus 2, so it's going to be the opposite, which is x minus 2, and then divide by 3. Okay, I want to write that a little different, so I'm going to say x minus 2 divided by 3. All right, type of function, that is still a linear function. L-I-N-E-A-R, there we go, pen finally, and applying the points. 0, 2 becomes 2, 0, right there. 1, 5 becomes 5, 1, 1, 2, 3, 4, 5. Basically, it's going to go up 1 for every right 3, up 1, 1, 2, 3, and it's going to look something like that. All right, domain, all real numbers. Range, all real numbers. Goes infinitely left and right, that's the domain. Infinitely up and down, that is the range. All right, I see myself getting crunched on time, so I better make this the last one. I'm going to do the quadratic, so x plus 3 squared. So that's just like x squared. Remember, x squared goes right through the origin like that. But the plus 3 means it moves 3 to the right. Now, I'm going to prove that, and I'm just going to use, 3 to the left, because it goes the opposite of what you would normally think. What's inside moves it left or right. What's on the outside, move it up or down. So plus 3. So if it was negative 3 plus 3 is 0. Negative 3 is 0. Negative 2 would be 1. 1 squared is 1. Same on opposite sides. If I use negative 2, that would be... if I use negative 1, That'd be 2, so that becomes 4. 2 squared is 4. 1, 2, 3, 4, and so forth. There you go. There's your graph. What type of function is this? This is quadratic. The domain would be all real numbers. The range would be y is greater than or equal to 0. And once again, this would not be a function because the inverse of this is not going to be a function. It's going to go this way. In fact, it's going to be down here in this case. All right, I want to get to the homework, so I'm going to skip by all that. Are the two graphs below inverses of each other? Now, I'm going to say they are not. And the reason I know is because I'm going to test it with a couple of points. This is 0, 3. Now, if that's 0, 3, then these are inverses. Then I know 3, 0, 1, 2, 3 must have been on the graph. And it is not. So that proves that these two are not inverses because I'm just simply testing one of the points. 1, it looks like 1, 4, so it should have been 4, 1. 4, 1 is right there. So it's going to end up looking like that when you do the inverse. Because remember, it's a reflection over the y equals x. Alright, determine the inverse of each of the functions. So I'll let you write that into your own words right here. The reason why, just listen to what I just said. Determine the inverse of each function, then type it and the type of each function. Then sketch the graphs and state the domain and range for each. Okay. So, this is multiply by 2 and then subtract 1. So, the inverse is going to be plus 1 and then divided by 2. Okay, once again, I need to write that higher. So, that's x plus 1 on top and then divide the entire function by 2. Or, you could say that's the same thing as 1/2 x plus 1/2. Or you could say that's 1/2 times x plus 1, which would be the exact same thing as well. Alright, so type of function, this is linear. And, okay, so pen's not working with me, so hopefully you're just watching the video. So that's linear, so that's going to start at -1, it's going to go up 2, right 1, up 2, right 1, 1, 2, right 1. Looking like that, so there's the original function. This function over here is going to start at 1/2. Oh, okay, so that's 0, -1 becomes -1, 0 right there. Come on, pen. This is 1, 1 becomes 1, 1. Okay, that stays the same. 2, 1, 2, 3. 2, 3 becomes 3, 2. 1, 2, 3, 1, 2. All right, and it looks like right there. And that makes sense because it's hitting the y-axis right here at about 1/2, and it's going up 1 for every right 2. Up 1, right 2, up 1, right 2, up 1, right 2. That makes sense. And that also has a domain of all real numbers because it's going left and right infinitely. It also has a range of all real numbers because it's going up or down infinitely. Yeah, you notice I made you watch the video because I didn't actually write all the answers in. Alright, thanks again for watching. Please give it a like to help you learn something about inverse relations, and please watch out for other videos. Thanks again for watching. Have a great day.